Hey everybody, fabulous chemistry students in our fabulous chemistry world,
MoNaCo here.
and Milks.
And for those of you who've been complaining about our side conversations in these lectures, we could lecture for 45 minutes every day all year long. So
In class.
10 to 15 minutes is a gift, so shut it.
Oh, here we go. Page 17, we're going to figure out what spontaneous reactions are. And we are going to use the activity series to help us.
And it ranks our metals according to reactivity. We saw this in acid and bases, and we used it to decide if a metal will react with acid. If it was above H2 on this chart, it does. It's actually in this POGL, the second POGL for this unit as well.
Okay.
In that same sense, reactivity.
Right, and it does say right in the chart, most active on top, least active on the bottom, so we don't have to memorize that. We can figure it out. So the more reactive metal is on the top.
Yep. And so a spontaneous reaction, what is it? It's a single replace reaction where the lone metal is more reactive than the bond metal. It will proceed forward without any additional energy input.
So basically, if I'm a chunk of solid pure metal that comes into contact with a compound that's metal is not as reactive as I am, I'm going to replace that non-metal, or that metal.
It's going to kick the other metal out. It says, I'm more reactive than you are. Let me have the ion.
Right.
And that's what happens. So
that's what happens. So
iron,
we
pure
look it
metal.
up. There it is, Fe.
Okay.
And then we find Ag, and we see that Ag is lower
than Fe. And notice we're ignoring nitrate. It's a spectator ion. It's
Correct.
not on table J. It has
Right.
nothing to do with the actual reaction except that it's the spectator.
It's hanging around. Think about a spectator at a football game.
Yep.
Doesn't influence the game really one bit. But because Ag is lower than Fe on our reactivity series, it will form a spontaneous reaction, which means it goes forward without me having to do anything to it. No energy added.
Except you have to let them collide and hit each
Well,
other.
that's kind of thing.
You have to
of
mix
course.
them, but
Right,
that's
right.
it.
But I don't have to do anything. It's going to do it all by itself. So that's why we get spontaneous.
A non-spontaneous reaction is one where the single replacement reaction has the lone metal that is less reactive than our bonded metal. So this metal sitting by itself is, ho hum, I'm happy by myself.
There's copper.
I see this other metal, sodium, in the compound, and I'm happy by myself, so I'm not going to go kick sodium out of his spot.
No, I'm not as reactive as sodium. Sodium is going to outreact me,
Right.
and so I can't take its ion. So for our purposes,
No reaction.
no reaction.
A little bit of practice examples here.
Let's do it.
So we're going to complete the products of the reactions that are spontaneous. If the reactivities indicate that the reaction is non-spontaneous, we will write no.
Oh, are we going to do this with, do you mind just talk it out? No pen?
I'll do one example with a pen so we can see how it crosses
Okay.
arrows
All
or
right.
not. And then,
All right, which one are you going to do so I know?
I'm going to do zinc and lead chloride. See what's up.
Okay, good. That's the first one, guys. The first one. So first I'm going to check zinc, and let's find it on our table. You don't have to draw these arrows. I mean, you just got to find it, okay? And then now lead, because I'm not worried about the ion, chloride. And then where is lead? Lead is below, so they are going to switcheroo.
They are going to react. So
Yes.
now that I know they will react, they can decide what it is they're going to make.
Well, they're just going to switch out, so it's going to be pretty easy. I'm going to take PB and put him by himself, and then combine ZN with the Cl2. Okay? ZN Cl2 with a PB. Done.
Is that a redox reaction, Mr. Milks?
It will end up being a redox reaction because I have a lone metal, which starts out as a 0 oxidation state, and then if I combine it with a chlorine, it must change, and vice versa for lead, it's just going to 0.
Right.
So I know that's a little fast, but you guys want us to speed these up.
Yeah, your fault, not ours.
So check out ZN and BA. ZN is, we just
pretty
did it.
reactive. It's in the middle of a series.
You know, and then is BA above it or below it?
Barium's mad more reactive than it.
No reaction.
No reaction. Barium's already got the oxide.
Yep. All right, moving on.
Calcium. And so what are our two products in there?
The same thing we started with because no reaction.
Oh, yeah, right. No
Yeah,
reaction.
no reaction. So CA, let me find my CA. Ooh, towards the top, just
Yep.
below CR. And then, or SR, sorry. And then I'm looking for CR, and CR is
at the
below
bottom.
it.
So calcium is more reactive than chromium.
So
which means
it's gonna go.
it's going to steal its
So now
state.
switch them.
So calcium forms +2, so it would be CaF2
Plus CR.
and Cr by itself.
Done.
That's what your product
Because
is.
that is spontaneous because the CA is higher than
I
the
want
CR.
to see.
No, don't write it. Don't write
I'm
it.
not going to write it.
Oh my.
This is how I know that you didn't write it, because if I I see 2 lines and a plus.
Oh, okay.
You weren't listening to
Oh,
us.
take it.
That's
Here
a
you go.
bar. 2 lines and a plus. You weren't listening to us.
Oh, manganese. Ooh.
And nickel. Manganese.
So where's Mn? I
Middle
see
of
it.
the road.
Yep, middle of the road, just above Zn. And
Nickel.
where's Ni?
Below it.
Below it, so they're switching.
Yep, they'll swap. They will react. So manganese,
Sulfide
MnS,
plus Ni.
nickel.
Nickel. Got it.
Iron and magnesium, Fe and Mg. Magnesium is more reactive than iron, so there's no reaction.
No reaction. Done. That one's easy.
NORXN.
Yep.
Cobalt and lead. Cobalt, middle of the road.
Cobalt. Yep.
Lead towards the bottom. Cobalt is more reactive than lead.
Not very, but enough that it'll go. So now
Cobalt
switch
chloride.
them.
COCl2 plus Pb.
Got it.
It's a wrap.
It's a
Moving
wrap.
on.
So now we basically just figured out how to use this reactivity series. We know what a spontaneous reaction is. You need to be able to tell me is the reaction spontaneous or not, and use table J to help you out.
That's it.
See ya!
Thank you.